Hello everyone and welcome back to my channel. Some of you guys may still remember this picture. It's actually the breakdown of a plasma light source during my test last year. However, today I managed to get an identical unit which has a decent price for me. So this time we will first do a teardown of this light source before it's break. So what we will do is that we will first power it up to visualize its start-up period, so that since it's hard to directly film inside the light output, which is this one here, actually it can rotate for adapt to different companies' products. So like I will just use the paper here to actually let you see the reflection light strength. It takes several seconds for it to reach the full power, and now it's actually set it at the maximum output power level. So let's do it. Maybe I should just put some, just like that. So okay, now I will turn it on. Actually at first it's very dim, we can directly film inside, but so it's on now. Okay, start and preheat. Takes several seconds. You can see the color actually changes. Okay, I think it's the full brightness now. Yeah, so just I can feel the heat. It's actually the light unit inside, which we will talk about in detail in this video, is actually rated at like 260 or 238 watts. I'm not quite remember, but we will see it. So you can see actually this unit is quite new. It's only used for 650 hours. The rated life is over 20k hours. This unit is only like $40 without shipping, so it's a really good price. So this is a power level. We can decrease it down to 50%. I'm not sure if you can see the difference in the light output, but since it's in 50 and it has a turbo mode, which is actually increase the power to 110%. So if I push that button, yes, it's increased. Maybe you can see it, I'm not sure, but let's just decrease it. Let's decrease now. Okay, due to the the exposure, it doesn't make sense. So, but the blue light, you can see the blue light is actually from this plastic here. So, yeah. So I will do the teardown, and I need to stop the video now. After tearing it down, we actually can see the power goes in from this inline filter with a fuse included, and comes to these two power supplies. This is an auxiliary power supply which powers this control board, and I also believe this and these three fans. This main power supply, you can see that the power connection is very thick wire and double wires for each pole directly comes, let me see, into this light source unit, and the control signal from this board comes through this coax cable or I shouldn't see the coax cable. It's actually like shielded cables, and it's 3 wires. Yep, into this light source unit, also the grounding of the different power supplies. So let's first take a look at this auxiliary power supply. It's a quite simple switch mode power supply. It doesn't have the power factor correction, and you can see the RCD suppression network. Yeah, like the main switching device. Sorry for the focus, but I will try. Yeah. IRF 1830. And what is this one? The control TL 3844. And for the feedback, the optical coupler. And actually this main power supply is quite high quality, and we can first take a look. It's 300 watt output, and yes, so 20 volts, but it says set at 28 volts. Actually this light unit is still warm, so has a cooling fan. And what is interesting here is that it's just like all the components are like located very good, and actually it contains the same as a small power unit, the EMI filtering. This one is only this one have, so it's a power factor correction. We can see the main inductor, the switching MOSFET, and the rectifier diode here. And yeah, this is a 4-bridge rectifier here on this heatsink, and the thermal switch for driving the fan, and 450 volts capacitor for the 240 input after the power factor correction, and the main switching MOSFET there. 300 watt switch mode power supply, good shielding, and several RCD, yes, RCD suppression network, feedbacks, optical couplers, and this chip here is actually CM6800. Yeah, I think so. Is that? Yes. So here I believe is the voltage regulator board for driving these feedback optical couplers, and for adjusting the output voltage, and just some filters, rectifiers, yes, and the loading resistor to reduce the instability of this power supply when it's I would say like low load operation without connecting to a load. So yep, let's do the teardown of this light source now. So after tearing down, this unit is break into 2 parts. This is the lens. You can actually see, not quite good focus, but anyway, so this one is, yeah, identical to the last time, that broken unit. And this is the small capsule which actually glows. very small, and it says that contains trace of mercury and argon. Yep, so you can see it's actually 240 watts. And we have the voltage controlled oscillator, a crystal, central controller, and the RF signal actually comes into this first stage amplifier and then goes through this trace here, coming to the second stage amplifier. This is also LDMOS, and goes into this final stage amplifier LDMOS, which is actually also a plastic package LDMOS. Its number, its serial number, you can actually see it here. Freescale, and some impedance matching network, filters into this resonant cavity. It actually contains some ceramic material, and this is class F amplifier. Class F amplifier. The drain feeding network, and this is the block diagram of this amplifier stages, and it has a bidirectional coupler. I'm not sure which one is the bidirectional coupler here actually. Let me check a bit. Feeling like this part is actually the bidirectional coupler, but I didn't see any connections back to this control board from that thing, so not sure how it functions. But you can see this is the drain supply, 28 volts. Sorry for that. So this is the ground, yeah, and here they are also grounding, and yeah, the ground signal drain supply for this amplifier. So this board here is just a driver amplifier and a class F amplifier. This should be the bidirectional coupler, not the filter. So yes, nothing else actually. You can see some very tiny inductors. These blue components, these small blue components, have the same package of these capacitors. These are actually inductors for feeding the gate of this MOSFET and the drain of this MOSFET. Let's see how this MOSFET drain is. Oh yeah, it's fed by this inductor here. Yes, and it's not, yeah, it's grounded. Yeah, this is where the bias comes in for this MOSFET LDMOS. It's actually from this wire here, this one here. It's gate bias control, and does this one has any gate bias control? Seems not. Oh yes, it has. There is an inductor here as well. This one here. Yeah, the gate bias control. And yeah, I believe this is all for today's video. Thanks for watching.